Hello. This lesson is about polygons. What is a polygon? A polygon is a two-dimensional shape which is closed and all of its sides are straight lines. So it's a triangle, all quadrilaterals, a hexagon, a pentagon, all are examples of a polygon. A regular polygon is a polygon with all its sides and all of its angles being equal. For example, here we have a hexagon which has got 6 sides. All sides are the same length and all angles are equal. That is an example of a regular polygon. In this case, a regular hexagon. Then when we add all angles inside a polygon, we will get a number which only depends on the number of sides or number of angles. Remember that for any polygon, the number or any closed shape, the number of angles, the number of angles and the number of sides are the same. For example, here I have a hexagon. It has got 6 sides and also it has got 6 angles. A pentagon has got 5 sides and also 5 angles. The number of sides and number of angles are always equal. Now, if they tell me what is the number of angles or the number of sides of a polygon, I will be able to find the sum of all angles inside the polygon. And that will be equal to the number of sides take away 2 times by 180. So whatever the number of sides is, take away 2 and multiply the resulting number by 180. The reason for that is we can build n minus 2 triangles inside the polygon, and because each triangle adds up to 180, so the angle sum will be that much. Let's look at an example. Find the angle sum of a pentagon. So we know a pentagon has got 5 sides. So all I need to do in this formula, replace n with 5. So then comes bracket 5 minus 2 close bracket times 180. 5 minus 2 is 3. 3 times 180 is 540. So the angle sum of a pentagon is 540 degrees. 540 degrees. Example 2, find each angle of a regular pentagon. As we said, a regular shape is a shape that has the same angles and the same sides in terms of the size. So all angles are the same, all sides are the same. Now from the previous part, because it's talking about a pentagon and we find the angle sum of a pentagon is 540, so we need to divide this by 5 to get each angle. So 540 divided by 5 gives us 108 degrees. So each angle inside a pentagon, a regular pentagon, is 108 degrees. Remember, this will not be the case if it wasn't regular. If it wasn't regular, each angle will be different. The next thing we've got to talk about is external angles. So here I've got a pentagon. And as you can see, it's not a regular one because angles are different and you can see the sides also are different. Now, this is a pentagon I have. If I extend one of the sides, for example, this is one of the sides, I'm extending it as you can see. Then the angle that extended side makes with the sides that's joining it will be an external angle. This letter is alpha, so alpha shows this angle. So here the letter alpha shows us an external angle, which is this angle. The fact about the angle sum of an external angle. So if we add all of this external angle, if I extend this one, and I make an angle here, I extend this one, I make an angle here, extend this one, angle, I make an angle here, and also this one, so I'm going to have 5 external angles, which in this case they are not equal. But always they are going to add up to 360, no matter how many sides we are talking about. So if it is a pentagon, hexagon, or even a square, or a rectangle, always the external angles add up to 360, or even triangle. Basically all polygons. They always add up to 360. Here we got an example. Find the angle sum of a regular pentagon and each external angle. Angle sum of a regular external. We should say this external. As to external, the external angle sum Okay, find the external angle sum of a regular pentagon and each external angle. So we know that regardless of what shape we are talking, the external angles add up always to 360. Because this is a regular, then they will be equal as well. So there are 5 of them. So 360 divided by 5 gives us 72 degrees. So each external angle in a regular pentagon will be equal to 72 degrees. One more thing before we finish this lesson. As you can see here, I've extended this side to get this external angle. I could have done other way around. I could have extended this one, this side like this, and then would have got this angle here. So it doesn't matter, that will be also fine. So we are going to have an external angle which will be equal to this angle. So when finding external angle, you can extend either of the two sides at any vertex or corner. That's all for this lesson. Thank you for your attention.